This is the story of a quiet countdown, in which a single sentence emptied an entire island. On a tiny island far out at sea, every inhabitant is a perfect logician. The instant a conclusion follows, they reach it without a moment's hesitation. There is an unbreakable taboo. No one ever speaks of eye color. With no mirrors and no pools of water, they see others' eyes but never their own. There is a cruel rule too. Anyone who becomes certain of their own eye color leaves forever on the midnight boat that night. And so they only counted in their hearts, and for ages nothing happened. Then one day, a traveler in the square idly lets slip a single sentence. That night the countdown begins, and the island empties out. The islanders had long seen plenty of blue eyes, so it was an obvious remark. How did it empty the island? Now it's time to nail down the rules of the game with no gaps. Everything hinges on the details. First, everyone is a perfect logician. Every conclusion that can be drawn they draw immediately, completely, and without error. Second, they see everyone else's eye color, but with no mirrors they never know their own. Third, eye color is never spoken of. The only information is who boarded the boat at midnight. Fourth, only someone who has logically deduced their own eye color leaves that midnight. Guessing is forbidden. This no-guessing rule is decisive. If someone could have left but didn't, it means they aren't certain yet. Silence itself becomes the foothold for the next deduction. Fifth, everyone knows these rules and that everyone is a perfect logician, and they know that everyone knows all the way up. This is the heart of it. Sixth, the traveler's statement is public and simultaneous. Everyone in the square heard it at the very same moment, and everyone knows that too. Finally, we count the moment the traveler speaks as night 0, and each midnight after as night 1, night 2. Since night 1 is the first night, this prevents being off by 1. Let's set the huge island aside for a moment. When things get dizzying, start with the smallest island. Let's follow islands with only 1, 2, or 3 blue-eyed people. If A is the only blue-eyed person, then looking around, the number of others' blue eyes is 0, nothing but brown. Then the traveler calls out, "There is at least one blue-eyed person on this island." Since A sees no one else with blue eyes, it must be A himself. He leaves on the first night. 2 people, A and B. A assumes that if I'm not blue, then B is the only one and leaves on the first night. But the first night passes and B doesn't leave. B was waiting in just the same way. And so A realizes, B not leaving means B saw blue eyes too, and that's me. With 3, each one sees 2 others. Suppose, if I'm not blue, those 2 leave on the second night. But the second night passes too, so it's not 2 but 3, and I'm one of them, leaving on the third night. Each time the silence piles up by 1, one possible head count is crossed off and certainty climbs 1 rung. What does it look like from the outside? Take an island with 4 blue eyes, and let 1 day pass at a time from left to right. The first 3 days stay quiet, then on exactly the 4th night the 4 vanish, and the 3 brown-eyed remain. Here is the general law. However many blue eyes there are, they all leave together on the night when exactly that many nights have passed. If there are 100 blue eyes, 100 of them leave at once on the 100th night, and not a single one leaves before then. Knowing it's 4, the 3 quiet days aren't surprising. The real reasoning lies in each person's assumption within an assumption. Why can't the brown-eyed ever leave? Because the traveler's words gave a clue only about blue and 0 information about any other color. The brown-eyed too, the day after all the blue eyes have left, get as far as "I'm not blue," but they can't pin down their own color. Had the traveler named Brown or spoken up once more, the same domino cascade would have worked for Brown as well. This much is easy. The real puzzle starts here. Picture an island with 4, no 100 blue eyes. On such an island, everyone has already seen at least 3 blue-eyed people. The answer to whether anyone has blue eyes was settled long before the traveler arrived. Not a shred of new information, old news, yet the countdown starts and the island empties out. How does one line of old news empty an island? It's the very heart most people drop when they retell this puzzle. The key is that we've been using the word "no" far too loosely. Let's climb the ladder one rung at a time to see exactly what that one line changed. Knowing has layers of differing depth, and how high you reach decides everything. Level 1 is the ground floor. Each person has seen someone's blue eyes, so everyone knows there are blue eyes. Level 2 is where I know that others know it too. Level 3 is everyone knowing level 2, and with no ceiling it keeps climbing infinitely. If only level 1 holds, it's mutual knowledge. If every level holds all the way up, it's common knowledge. Common knowledge is everyone knows stacked infinitely upon itself. The bare fact was old news, but one public line lifted it to common knowledge in a single stroke. Take two people with blue eyes. A has seen B's blue eyes, so level 1 holds. But A has a doubt. If my own eyes aren't blue, then B sees 0 pairs of blue eyes and might not even know that fact. Before the words, A couldn't be sure of the second floor, and the one sentence fills that gap. What became new wasn't the fact, but the upper floor. Let's see this ladder as a picture. The height of the red dashed line is the key. Before the words, with 2 people you reach only the first floor, with 3 only the second, always 1 floor short of the number of blue eyes. With just 1 person they see 0 blue eyes, so it's empty from the very first floor. Private hints build 1 floor at a time, but a public sentence fills every floor above, up to infinity all at once. The traveler's one sentence built the tower of knowledge infinitely high while sounding the starting signal, night 0. Without a common starting point, not even perfect logicians can sync their countdown. One last question. Why do the dominoes fall all the way down without skipping a single one? The answer is inside the islanders' minds. Let's follow on an island with 4 blue eyes. A imagines, if I had brown eyes, there would be only 3 blue eyes. One of those 3 and then one of those 2 imagines the same way, dropping it to 2 then to 1. This chain finally hits bottom on an imagined island with just 1 blue eye. That one person sees no blue eyes, so once the statement is made, they leave on the first night. The depth of imagination is exactly what sets the number of nights. Let's look at the picture. The real island has 4. 1 layer in 3. Another layer 2 at the bottom 1. There are 4 imaginary islands in all, and that matches exactly the 4 nights it takes to leave. Let's be clear. These boxes are the nested hypotheticals inside one person's head, and the island at the bottom collapses solely because of the traveler's remark. Without the remark, the chain never reaches the bottom, it just keeps falling forever. Let's set the explanation aside for a moment and empty the island ourselves. The original article has a simulator. Set the number of blue eyes, have the visitor make the announcement, then hit next night to advance 1 day at a time. And then the very domino cascade we proved plays out exactly. Everyone leaves all at once on the night equal to the number of blue eyes. You really should try it. Hit next night before the visitor says anything. Even as they stare straight at each other's blue eyes, nothing happens for days. What you know privately just sits there. The only trigger is the public remark. Click a dot, and you step into that person's first-person view, showing only the number of blue eyes they see, and their level of certainty. Your own eye color is a question mark, you can't see it. Try picking a blue-eyed person and a brown-eyed person in turn. On the same night, the certainty in the 2 heads diverges. On the night the blue-eyed people leave, a brown-eyed person realizes, so I'm not blue, but never learns their true color. That's the moment common knowledge creates. Now let's leave the island and come to our own world, because the same structure is at work all over the place. Even a fact everyone knows privately has no power until it becomes common knowledge. The first story. The emperor's new clothes. Everyone saw it, yet no one could open their mouth. Then a child cries out, and the spell is broken. The child told them no new fact. The cry heard together turned it into common knowledge. It differs from the island. The tale shows only a single moment trigger. There is no multi-day cascade, and a separate question of courage is mixed in. Second, the public square and assembly. Michael Chu says so in Rational Ritual, 2001. Public rituals and Super Bowl ads are powerful because they make everyone know that others know too, binding actions in one direction. A revolution is the same. Even discontent does not lead to action before it becomes common knowledge. This is the theory of preference falsification by Chu and Timur Kuran. Factors like organization and resources also come into play. Last is the exact mirror image, a classic of distributed systems, the two generals problem. With untrusted messengers and a lossy channel, the reply confirming receipt goes on endlessly, making a simultaneous attack impossible. On the island, a public broadcast raises the infinite tower in one stroke and succeeds. The two generals fail because the lossy channel cannot even clear a finite height. A single cry, public and simultaneous. The two stories illuminate from both sides where its power comes from. Time to wrap up. Let's return to that very first question. How did one sentence everyone already knew empty the island? The traveler did not announce a new fact. He changed no one's eye color. He changed only the standing of a fact that already existed. He lifted private knowledge up one rung, into the common knowledge that everyone knows that everyone knows. That single step up was enough to empty the island, over a cascade of nights. Behind the single word "know" that we use as one lump, there are actually 3 hidden layers. Some truths stay silent in the mind, then move the world the moment they are spoken aloud. When you feel that air where everyone knows yet no one says it, remember this island. What changes everything is not a new fact, but the single moment of hearing together what was already known. This is a classic of epistemic logic and common knowledge, also known as the cheating husbands, the unfaithful wives, or the muddy children. Its roots go back to Littlewood's 1953 book and Gameov and Stern's 1958, 40 Unfaithful Wives. And Gardner popularized the variants. Today the blue eye/island/guru form spread through Monroe's XKCD, but he made clear he had only written up the definitive version he heard from Joel in Boston. Don't get them confused. Beloz's 1996 The Hardest Logic Puzzle Ever is a completely different problem about 3 gods. The concept's origins trace to Lewis's 1969 book, Aumann's 1976 paper, and on to Tao's 2008 blog exposition. If you enjoyed today's story, please subscribe, like, and turn on notifications. See you in the next video.